2.2 Environmental controls. The key terms for this section include: term definition. Line conditioner, a device that modifies the power signal to remove noise and create a smooth alternating current, AC, signal. Standby power supply, an offline device that goes online to provide power when an undervoltage event occurs. Uninterruptible power supply, an online device that is constantly providing battery power to the computer and being recharged by the wall outlet.
In this lesson, we'll talk about some of the environmental concerns that you'll need to be aware of when you work on computer systems. First, let's talk about disposal. As a PC technician, you'll come across materials that need to be disposed of in a specific manner. Most communities have laws that dictate which materials you can and can't put into the common trash. Environmental laws vary from state to state, so be sure to check your local laws for directives on handling things like batteries, printer cartridges, monitors, and PCs. With that in mind, let's talk about some general rules you should abide by. Let's first discuss batteries. Proper battery disposal can be confusing because disposal guidelines vary for different battery types. For example, in most states, you can throw alkaline batteries in the regular trash, but in other states like California, you can't because they're considered hazardous waste. Instead, they must be disposed of with the Household Hazardous Waste Collection for special recycling. Laptop and notebook battery disposal is an environmental issue as well. Most laptop batteries today are lithium-ion batteries. The problem with this type of battery is that it usually doesn't last more than 2 or 3 years. If you service or support notebook systems, you'll find that you replace batteries for your users frequently. The question is, what do you do with the old ones? In most communities, it's illegal to throw these batteries in the common trash because they're loaded with toxic chemicals and need to be disposed of in the manner dictated by the local community. Contact your local environmental management office to see if there's a recycling facility available. If there isn't, find out what they recommend you do with those old batteries, but don't just dump them in the trash. Another environment issue is printer cartridges. Printer cartridges go dry or run out of toner. If your organization has a lot of printers, you're going to have a stack of old ones in a very short time. In most communities, these empty printer cartridges should be recycled. Some manufacturers accept the empty cartridges back from you, refill them, and then resell them. This reduces landfill waste, provides the manufacturer with a cheap product, and provides you with a source for less expensive printer cartridges. You can usually purchase a recycled printer cartridge for about half the price of a brand new one. Another issue is the disposal of computer monitors. LCD, plasma, and CRT monitors are all considered hazardous waste. These types of monitors can leak lead and other toxic chemicals into the environment and should never be thrown in the landfill. In fact, in many places, it's illegal to do so. In addition, some of the older cathode ray tube, or CRT monitors, can retain a large electrical charge. Even if you've had one of these monitors sitting unplugged in a closet for months, there's a capacitor inside that retains a very hefty AC charge, maybe up to 20,000 volts. It could be a shocking experience to touch one of those. The disposal of old computer systems is another concern. One of the great ironies of the modern information age is the fact that the computer system you bought a year ago for thousands of dollars will be worth substantially less today. As a PC support tech, you're probably going to find yourself throwing away a lot of old PC systems. But again, don't just throw them in the trash. As with batteries and monitors, it's probably illegal to do so anyway. In addition, you should discharge and recycle a desktop system's power supply. The good news is that with a PC system, there's a lot of precious metals inside which can often be recycled. There are many companies that recycle these systems to extract the gold, silver, and other materials from inside. They'll pay you, although not much usually, to give them your system so they can pull the metals out. Once again, check with your local environmental management office to find out what the laws are regarding disposal. Ask them if there's a recycler who will take your old system for you. Be sure to refer to your organization's Material Safety Data Sheet, or MSDS, for the preferred disposal methods for batteries, printer cartridges, monitors, and PCs. Now let's talk about air quality. Computer systems don't function well if they get too cold, too hot, too humid, or too dry. Poor environmental conditions can reduce your network component's lifespan, as well as decrease their reliability over time. The hotter that computer equipment runs, the faster it ages and degrades. And if a system were to get hot enough, it's possible for hardware components to be destroyed. While you can use internal fans and cooling systems to maintain the internal temperature of your laptops and PCs, you should also pay attention to your offices, server rooms, and data centers. The general guideline is to try to keep the temperature at 68 degrees Fahrenheit, but cooler temperatures can be even better, especially in server rooms and data centers where there are a lot of systems. Computer systems don't function well with too much or too little humidity either. Computers are designed to operate within a humidity range, so you need to monitor the humidity within your organization. Too much humidity results in condensation, which is bad for electronic equipment. Too little is also bad because electrostatic discharges are more likely. The drier the air, the more easily static sparks can jump and damage components. The recommended humidity level is usually around 40 to 60%. Now let's talk about cleaning. Although you may wipe your screen and keyboard down occasionally, you probably don't think too much about the cleanliness on the inside. However, a clean computer is important. Having a buildup of dirt and dust can slow or even stop mechanical parts and cause your computer to overheat. Ideally, you should use a compressed air or non-static computer vacuum to remove dust and dirt from inside your computer. Sometimes you might even need to use a damp cloth with mild soap. But be sure to not use strong solvent-based cleaners on your devices, especially your monitors, as they can create discoloration, damage, and buildup. And be sure to turn off all power before putting anything wet near an electrical device. It's best to refer to your organization's MSDS for preferred cleaning solutions before you start. That's it for this lesson. In this lesson, we discussed disposal methods for batteries, printer cartridges, monitors, and PCs. We also discussed the importance of maintaining air quality and keeping our computing devices clean.
Two point two Environmental facts disposal. It is important to ensure that equipment and hazardous chemicals are disposed of properly. Consult the manufacturer's documentation for recommended solutions for equipment disposal. Consult an MSDS for information on physical data, toxicity, health effects, first aid, storage, disposal, and spill procedures for disposal of hazardous chemicals. You can download a material safety data sheet, MSDS, from the manufacturer's website or check with the representative of that organization. Your company may also have an MSDS in place for disposal that you can refer to. The following table offers suggestions for disposing of used equipment, component or material disposal method. Alkaline batteries. Recycle alkaline batteries if possible. Otherwise, dispose of alkaline batteries as your local laws require. For example, in some states, you can throw them in the regular trash. In California, they are considered hazardous waste and are supposed to go with the household hazardous waste collection for special recycling. Button batteries. These are considered hazardous waste because they contain mercuric oxide, lithium, silver oxide, or zinc air. Return them to the manufacturer, recycle them, or contact local authorities for disposal procedures. Nickel metal hydride, NiMH, batteries. Recycle NiMH batteries. Lithium batteries are considered a non-hazardous waste. CRT monitor. Contact local authorities for recycling CRTs. They contain many toxic and caustic substances that are illegal to incinerate. Discharge CRTs before disposal, as they can contain high voltages. PC system recycle, give it away, or resell old PC systems. A typical PC contains $5 to $25 worth of precious metals. Remember to clean the hard drive before disposing of the machine. Power supply, contact local authorities for regulations. Recycle power supplies if possible. Discharge before disposal, as they contain high voltages. Laser printer toner cartridges, return cartridges to the manufacturer for recycling. To clean up spills, use a toner vacuum or a scoop and a damp cloth. Never use a regular vacuum. Inkjet printer cartridges, recycle these cartridges. You can return the cartridges to the manufacturer for recycling or recycle them yourself. Cleaning solutions and solvents, consult the MSDS, a licensed disposal organization, or local authorities for handling and authorized disposal procedures for solutions and solvents. Air quality, computer systems do not function well if they get too cold or too hot or too humid or too dry. Poor environmental conditions can reduce the life of network components, as well as decrease their reliability over time. The following chart provides information on a few air quality factors. Temperature: the hotter computer equipment runs, the faster it ages and degrades. And if a system is hot enough, it is possible for hardware components to be destroyed. Internal fans and cooling systems can typically maintain the internal temperature of your computers. External temperatures of offices, server rooms, and data centers should be monitored. The general guideline is to try to keep the temperature at 68 degrees Fahrenheit, but cooler temperatures can be even better, especially in server rooms and data centers where there are a lot of systems close together. Computer systems do not function well with too much or too little humidity. Computers are designed to operate within a humidity range, so you need to monitor the humidity within your organization, especially in your server rooms and data centers. Too much humidity can result in condensation. Too little humidity can result in electrostatic discharges. The drier the air, the more easily static sparks can jump and damage components. The recommended humidity level is usually between 50 and 65%. Ventilation: good ventilation can go a long way in maintaining temperature, humidity, and airflow. PCs and laptops should be used in an area where there is plenty of space for air to flow in and out. Server rooms and data centers often use hot and cold aisles that are designed to ensure that hot air is removed, and cool air is pushed into the room. Cleaning: a buildup of dirt and dust can slow or even stop mechanical parts and cause your computer to overheat. The following cleaning tools can be used to maintain your systems. Computer vacuum, used to remove small bits of dust and dirt. Be careful using near small components. Damp cloth: a damp cloth with mild soap and water can be used to clean the outside of a computer and monitor. Be sure to unplug any electronic device before cleaning with water. Denatured isopropyl alcohol: denatured alcohol can be used to clean metal contacts, like those found on expansion cards. Compressed air: use compressed air to blow small particles of dust and dirt from inside your device.
In this lesson, we're going to talk about protecting power. A critical part of protecting your PC is managing the electrical power that reaches it. At some point, you will have problems with power. The question isn't if it will happen, it's when. So let's look at some things you can do to protect your systems. The first problem you might have is a power surge. A power surge happens when you get an increase in voltage that can last for seconds. A power spike is like a power surge, but it lasts milliseconds instead of seconds. In either case, instead of getting 110 or 120 volts from a wall outlet, you get a surge of extra volts. It doesn't happen very often, but it can, especially if there's a lightning storm. A power sag is a decrease in voltage. You could be getting 110 to 115 volts from the wall socket when the voltage suddenly drops down to about 80 or 60 volts. Brownouts can happen when there's too much demand on the electrical grid and there isn't enough power for everyone who wants to use it. The decrease in voltage lasts for several seconds. The power doesn't go out completely, but the lights dim. The last problem is a blackout. A blackout is a complete loss of power. Blackouts happen when there's a short, a tree or high winds knock down a power line, or a transformer blows out. All of these power issues are real problems for your PCs because if you lose power, your whole system goes down. And if that happens, you might lose data. Most organizations' most valuable asset isn't their buildings or their parking lots, it's the data they create and store. So, you need to do everything you can to protect that data. Your first line of defense against data loss is a surge protector. Surge protectors and suppressors filter power surges before they reach your system. Suppressors condition the power, keeping too much from reaching the device. Protectors detect the surge and turn the device off before damage can happen. These devices are good, but they only protect you from surges. Surge protectors don't protect you from power sags, brownouts, or blackouts. To protect systems from those problems, you need to use an uninterruptible power supply or UPS. A UPS is a battery backup for your PC. When the power goes off, the UPS kicks in and supplies power for a period of time. Most UPS units also provide power conditioning like a surge suppressor. They protect your equipment from power spikes, sags, brownouts, and blackouts. So which systems should you protect with a UPS? Well, that depends on your organization's values and needs. In some organizations, all the PCs need to be protected, so each server and workstation has its own UPS. For other organizations, the workstations aren't critical, but the data on the servers is absolutely critical, so they'll install a UPS on just the servers because they're running a web server that customers use to purchase products, or maybe a database where users save information. Either way, you need to decide which systems need to be protected and which ones don't. Then you need to decide between two types of UPS systems. The first type is an online UPS. An online UPS is definitely the best kind, but it's also the most expensive. When you use an online UPS, the PC doesn't draw power directly from the wall outlet. Instead, it's constantly fed by the battery in the UPS. The UPS continually recharges the battery, which the PC system continually draws down. Because an online UPS uses the battery constantly, it wears out really fast. You have to replace either the UPS or the battery inside the UPS frequently. But if you need the best protection, it's worth the cost. The less expensive alternative is an offline UPS. It looks just like the online UPS, but it functions differently. So here we have a bridge. The UPS uses the 110-volt current coming in to charge the battery. It also bridges the current from the outlet over here to the system. That means instead of running on the UPS battery all the time, this system runs on 110 volts from the wall. The battery charges and then it just sits there. If it loses power over time, it's topped off, but it doesn't do anything unless there's a power issue. If the current coming out of the wall drops below 80 volts or so, like in a brownout or a blackout, there's a switch inside the UPS that breaks the connection here and then converts over to the battery. Then the PC starts running off the battery. Now, because you're not continually draining and recharging the batteries in an offline UPS last a lot longer than the batteries in an online UPS. But an offline UPS has one critical disadvantage. The power switches from the wall current to the battery. During this switch, there's a millisecond of time when the system doesn't receive any power. There's usually enough power stored in the PC's power supply to keep the system running for just a few milliseconds while the power switches over. But if your power supply is too small for your system and it's barely keeping up with the demand, you could have a problem. That's why many companies use an online UPS for really critical systems like servers. You don't want the power to go down on a server. For workstations, many people use an offline UPS because they're less expensive, and if the system goes down, it isn't as painful. Use your organization's values to decide which type of UPS you need for each device. When you select a UPS, look at the battery power. Some UPS devices have larger batteries and can supply power for a longer period of time. Look on the box for a rating that says how long the battery will last. It'll say something like, this system will power one PC for 20 minutes. But be aware that these time ratings aren't very accurate. A general rule of thumb is to plan for about half of the time advertised and use the rest of the time as a cushion. Also, if you plug more than one PC into the power supply, then you need to cut the amount of time in half again. Keep these factors in mind as you choose a UPS. Be sure you get one that will provide the power you need for as long as you need. Now let's look at how to configure a UPS system. Let's say that you just bought a UPS. What do you do with it when you get it home? First, plug it into the wall outlet. Most UPS documentation says to charge the UPS for 12 to 24 hours before you use it. When the battery is fully charged, plug a server or workstation into one of the protected outlets on the UPS. Many UPS devices have 5, 6, or 7 outlets, but only some outlets are protected by UPS power. The rest are conditioned power. The conditioned power outlets act as a surge suppressor. If you plug your system into one of these other outlets, you're not going to have any battery backup power, so make sure you plug the PC into a protected outlet. A UPS's purpose is to keep your system running long enough to shut down cleanly without losing data. What happens if you don't shut it down before the battery runs out? Your system will power off without protection, and your UPS can't do anything to save any data. To avoid this problem, you need to configure the UPS to work with your PC system and make sure it shuts down cleanly before you lose all your battery power. To configure automatic shutdown, we'll connect the management cable, usually a USB or serial cable, from the UPS to the PC system. The management cable allows communication between the UPS and the operating system running on the computer. Using this cable, the operating system can monitor the state of the battery, see how much charge the battery currently has, see if the battery is charging correctly, and send shutdown commands to the operating system. After the cables are connected, we'll load drivers that can communicate with the UPS on the PC. So, when the UPS loses power over here, the UPS will send a signal through the serial cable to the drivers running on the PC, and then the system will respond according to its configuration. For instance, if the power goes out, you may say, wait 10 minutes and then shut down. Or, if the power goes out, immediately shut down the system cleanly. Most UPS devices come with some kind of software that's used to configure system behavior in the case of a power outage. In this lesson, we talked about the different power problems you can have and the tools you can use to protect your systems from power damage. We talked about online UPS systems and offline UPS systems and how they can provide a temporary power source during a power outage. We also talked about how to choose a UPS and how to automatically shut down a PC in the event of a power loss. It's sort of a joke among IT professionals that the day you decide to purchase a UPS is the day after you've had a power outage and lost a lot of data. Do yourself a favor and implement a UPS before the power goes out.
In this demonstration, we're going to discuss how to configure uninterruptible power supplies, or UPSs. Using a UPS is a really good idea, especially for sensitive systems. It maintains AC power to the battery in case of a power outage. This gives you time to bring your system down cleanly. Remember, Windows doesn't like unclean shutdowns. They can corrupt and discard data. Before we talk about how to configure a UPS, we need to bring up one key mistake that a lot of users make. People often plug their system's AC cable into a protected outlet on the UPS but they don't ever connect the management cable. Most UPS systems have a USB cable that you can plug into your PC system, which allows communications between the UPS and the computer's operating system. Using this cable, the operating system can monitor the battery's charge. In return, the UPS can send commands to the operating system to shut down. For example, if a power outage happens, the UPS can send a command to the operating system saying, "We need to shut down because my batteries are going to run out in 5 minutes." If you don't connect the management cable, there's a chance that the UPS's battery capacity will be shorter than the duration of a power outage. So, how do we set this system up? First, we plug the UPS system into a wall outlet. When you initially purchase a UPS, the battery will probably need to be charged for quite some time, maybe even overnight, before it reaches 100%. Okay, so now I plug my PC into one of the protected outlets on the UPS. Be very careful with this because you'll often find that only some outlets are battery backed, and others only provide surge protection. If you plug your PC into a surge-only outlet, you won't have any battery backup. Alright, next we need to plug in the serial or USB cable from the UPS to the PC system and install the management software. I've already done both of those things. As you can see, I have UPS software installed and running on my Windows PC. The actual software you use will depend upon which UPS you've purchased. The APC company provides a popular UPS system that uses PowerShoot software. That's what we're using here. When we start the PowerShoot application, the Monitor Your System tab is displayed by default. Here we can view a summary of historical power events that have occurred, and we can also view battery backup status information. We can see that electrical power is currently supplied by the AC utility power. In other words, this system is running on AC power from the wall outlet. Right now, it's not running on battery. The battery here is 100% charged. We haven't had a power outage, and we haven't had to switch to battery power recently, so no historical battery events are recorded. And here we see that the input voltage coming in from the wall outlet is 120 volts. Now we know that the UPS is functioning properly, we're all hooked up, and everything's ready to handle a power event. Now it's time to make some configuration changes. Let's go down to Options. One of the things we can do is click Enable PowerShoot Notification Sounds. A lot of people turn this function off because when the power goes down, it makes a really annoying sound. In my opinion, though, it's a good idea to have this enabled. It gives you audible notifications that the system is running on battery power. Let's go to Runtime Configuration. This is probably one of the most important configuration screens. We have two different options here: preserve battery power and keep my computer running as long as possible. This one basically says that if a power outage occurs, it should run on battery until it's down to about 5 minutes left in the battery capacity. At that point, initiate the shutdown. It's set to 5 minutes because sometimes it takes a few minutes for a computer to shut all the way down. We want to make sure that there's plenty of time for the shutdown to occur because there's no point in having a UPS if it runs out of battery in the middle of the shutdown process. You're almost guaranteed to end up with corrupted files somewhere if that happens. The option I like better, though, is preserve battery power. Instead of keeping a system running as long as possible, with this option we're saying, just please shut down this computer after it's been on battery backup for a very short amount of time. In this case, it's set to 5 minutes. So if we have a power event and the power doesn't come back on within 5 minutes, this computer system is going to shut down automatically. I prefer this option because sometimes, like during a storm, the power goes off and on several times and the battery starts to drain. I like to wait until the power event is pretty much over so that my system doesn't go back and forth between battery and normal power. If you use the first option, you might not have enough battery power left in the UPS to shut the system down cleanly. If you use the second option, on the other hand, you'll still have plenty of battery power left for whatever you need to do. As you can see down here, my estimated battery time is 343 minutes. Let's go ahead and click Apply. Next, let's go to our notifications. Here we can configure our battery backup alarms. The option we configured earlier was the PowerShoot notification sounds, meaning that Windows itself is going to pop up a notification and generate a sound to let us know the system is on battery power. Here, we're configuring the backup battery unit itself. If you've ever had the power go off and heard the horrible beeping sound that the UPS makes, you know how loud it can be. We have several different options. We can enable the backup battery alarm at all times, or we can disable it. That's probably not the best idea because you want to know if the power has gone off and that your system is now running on backup battery. Here's the Enable option. I don't like this option because it could kick off in the middle of the night when I don't really care. So the default option is the better one. Basically, it enables the backup battery alarm during the workday. So we're going to let the UPS shut down the operating system cleanly. We'll leave that set to its default value. Let's go down to sensitivity. This is where we specify the circumstances when we want the UPS to kick in. Remember that your UPS not only protects your system from power loss, but also from electrical noise. So if the UPS detects enough electrical noise on the input power coming from the utility company, it can shut that off and use battery power in order to protect your equipment. That's a good thing. We have 3 different sensitivity levels. Low causes the system to switch to battery power less frequently, but it could, as it notes here, allow greater voltage distortions to reach your computer, which could potentially damage your equipment. Medium is a good setting because it switches the system to battery power when moderate amounts of voltage distortions hit the computer. If you want maximum protection against electrical noise, you can select High. Be warned, though, that almost all utility companies have a certain degree of voltage distortion coming in through the AC power line. Depending on the company, the high setting could cause the system to use the battery constantly. That's why medium is selected by default, and my experience has been that this is just about right. We'll leave it at the default value of medium. Now, let's come down here and select voltage. In this screen, we essentially define what a power event is. We specify a high and low voltage threshold. Normal utility voltage is between 115 and 120 volts. If the AC utility voltage goes above 139 volts, we're going to go on battery because we're assuming that some kind of spike is coming down the line, and we don't want that. If the voltage drops below a certain value, in this case 92 volts, we're going to assume that we're dealing with a brownout of some kind. Once again, we want to go on battery. I usually leave these set to the default settings, but you can adjust them. Down here you can see what the current power source is. We're running on AC utility power, and the estimated battery time is 343 minutes. Now, this brings up a really important point. This estimated battery time assumes that there is one PC connected to this UPS. Oftentimes, people plug multiple systems into one UPS, and that drains your batteries faster than this estimate. My advice is to never connect multiple PCs to the same UPS. I know the temptation is there, but I'd recommend that you implement one UPS for each PC system to get the full estimated battery time. A lot of PC techs like to connect other devices to the UPS as well to keep them up and running. That's okay as long as the devices don't draw too much power. For example, I know a lot of system techs that work with small businesses, and they connect the organization's switch to the UPS so that networking remains enabled during the power event. That's always a good idea. In addition, they connect their internet equipment, like their router or cable modem. Again, that's not a bad idea. It keeps all your network connectivity up and running in a power event. And because the switch and the cable modem don't really draw much power, it doesn't affect the estimated battery time very much. There's an ongoing debate as to whether you should plug your monitor into your UPS as well. You can. In fact, I usually do. But just be aware that it cuts down the estimated battery time because monitors do draw a lot of power, although it's not as big a deal today with LED and LCD monitors. The one thing that you should never connect to a protected power outlet on your UPS is a printer, especially a laser printer. That's because laser printers have heating elements that consume a huge amount of electricity, and they'll drain the UPS battery very fast. That's it for this demonstration on UPS settings. In this demo, we talked about implementing and configuring a UPS for power events.
2.2.5 Power Concern Facts Conditions. The following table lists power conditions you should be familiar with. Surge over voltage that lasts seconds, spike over voltage that lasts milliseconds, sag under voltage that lasts milliseconds, brownout under voltage that lasts seconds, lights may dim, blackout, complete power failure devices. The following is a description of devices used to prevent power problems. Surge suppressor. A surge suppressor conditions power so that overvoltages don't reach devices. Surge protector. A surge protector protects against overvoltages by switching a device off before an overvoltage can damage it. A power strip provides multiple power outlets from a single plug-in but is not necessarily a surge protector. Surge protectors can be destroyed by surges and lose their ability to protect. Consider using a surge protector with an indicator light to show whether it is working correctly. Line conditioner. A line conditioner modifies the power signal to remove noise and create a smooth conditioner alternating current (AC) signal. Standby power supply (SBS). A standby power supply is an offline device that switches over to provide power when an supply undervoltage occurs. If the switchover is not fast enough, the computer loses power. Uninterruptible power supply. An uninterruptible power supply is an online device that is constantly providing battery power to the computer and being recharged by the wall outlet. There are two types of UPS systems. An online UPS constantly powers the computer from the battery. An offline UPS powers the computer from the wall power. When the power fails, a switch inside the UPS switches to power the computer from the battery. This is the most common form of UPS. UPS size is measured by the volt-amp (VA) rating. The capacity of the UPS determines the number of devices and how long the devices can run when power is interrupted. When purchasing a UPS, purchase one with enough battery power to power only critical devices such as the computer and a single monitor. To reduce the amount of power required by the UPS, do not plug non-critical devices into the UPS. Laser printers require more power than most UPS systems are capable of providing. For this reason, you should not connect a laser printer to a UPS. If you must provide power to a laser printer, get a dedicated UPS for that device. UPS. A UPS is designed to provide enough power to shut a system down safely during an extended power outage. Most are not intended as long-term power solutions. The UPS connects to the power source, usually a wall socket, the computer plugs into the UPS, and the UPS is connected through a serial or USB port to the computer. Software on the computer uses this connection to monitor battery life and to detect when the regular power is lost. You can configure the software to shut the system down automatically when the battery charge reaches a certain level. You usually need to configure the following settings when working with UPS software: time to wait before sending a warning to clients. Time to wait before beginning a shutdown. Name of programs or commands to run during the shutdown. In addition to providing power when the power is lost, most UPS systems also condition the line and remove power spikes and sags. Most UPS devices sound an alarm when the AC power is lost. This alarm continues until AC power is restored, although many UPS devices have a switch to mute the alarm. During certain conditions, such as an electrical storm or when the power supply is constantly going up or down, you might need to unplug the computer to protect it. Simply turning it off might still damage the components because some power remains supplied to the system. In the case of an electrical storm, Keeping the system plugged in leaves it susceptible to power spikes.
Greetings, I'm Professor K, and in this short video presentation we're going to take a look at how we go about completing the lab for our Test Out PC Pro version 6 course, Lab 2.5.6, Install a UPS. So what we're going to do is we're just going to walk through each one of these requirements here as we do the lab, and then we'll see exactly what areas we have to focus on to complete the lab and get a 100% passing score. Let's go ahead and start the lab. So in this first step of the lab, we have three things we have to do. We have to add a UPS to our computer. We have to plug the UPS into the wall jack for power. Then we have to turn the UPS on. So let's go ahead and get that done. So here's my outlets. I'm just going to grab that UPS. I'm going to drag it right here like so. Now the next thing I'm going to do is take this partial connection that we have here, and I'm just going to plug it into the AC outlet on the wall jack. Now my UPS is plugged in. I'm just going to go ahead and start it by powering on the device using the power button. That takes care of requirement number 1. Now requirement number 2 says plug the computer and the monitor power cables into the appropriate UPS outlets. Alright, so you have two different types of outlets on a UPS. Some of them are going to be for battery backup, and some of them are going to be just for surge protection. Now we need battery backup for our computer and for our monitor. So let's make sure that we get these power cables plugged into the right outlet. So I have a partial connection here for my computer. So I'm just going to grab this. I'm going to go up here to the battery backup side of the UPS and let go. Now my computer is plugged in to the battery backup side of the UPS. I'm going to do the same thing with my monitor. Click on the partial connection. Let's see if I can get this thing to show up. There it is. Now I'm going to take that male connector for the monitor, and I'm going to also place it right next to the power plug for the computer. So let's talk about the purpose of a UPS. An uninterrupted power supply provides you with enough power, battery backup, so that you can gracefully power down your computer and your monitor. It's not designed so that you can continue working uninterrupted. That's not the purpose. It's so that your machine does not become corrupted when you suddenly lose power. Now in this case, we also have surge protection, or as I like to refer to it as conditioning. There's nothing that will wear out a computer or any electronic device quicker than dirty electrical current. And that's something that the UPS also provides, line conditioning. But it also provides surge protection. So now I'm going to go over here to my printer, and I'm going to add it to the UPS. So I'm going to click on my printer. I'm going to scroll on back over here to the UPS. Now, again, the printer does not need to have battery backup. It needs surge protection. So I'm going to take that partial connection, and I'm going to plug it down here, like so. Now, the next thing we have to do is connect the network cables through the UPS to the computer. And it tells us the cable from the wall connects to the in port. Well, we already have a network cable connected to our computer, but that cable should be plugged into the in port of our UPS. So let's look at the back here. So there's that network cable. So I'm going to go ahead and look at the side view here, and we're going to go ahead and bump this up just a little bit. And the in port is down here. This is the out port. So I'm going to take this cable from my computer, and I'm just going to place it right here into the in port. And now my network cable is coming from the wall to the in port of my UPS. All right, but now we need another networking cable to go from the out of the UPS over to the RJ45 connector on my computer. So let's see how we do that. So here we have the RJ45, or the Ethernet cable that we need. So I'm just going to click on it like so, and I'm just going to drag it on down here to the out on the UPS. Now I'm going to take the unconnected side of that cable and I'm going to place it here on my computer, like so. Another feature of a UPS is that it comes with software that can monitor your computer. And you can say in the configuration of that software that in the event that my computer loses power, I want you to gracefully shut down my machine. And the software should do it. That's in case you're not available to gracefully shut down the machine manually. But for this to happen, there has to be a connection between the UPS and the computer. Let's see how we do that. And so here is the UPS cable we have to use. Go ahead and click on it. And you have two different types of connectors. This one over here I like to refer to as a printer type connector. It's something you would actually see for your printer, or in this case for the UPS. And we're just going to drag that right here. We're going to plug it into that UPS port down here at the bottom on the side of the UPS. Let it go, just like that. Now all you got to do is just take the UPS connector on the other end of that cable, and you're going to find a USB port on the computer, connect it, and let it go. Now everybody's connected. And so that should conclude the steps needed to complete this lab. So let's run that lab report and let's see what we got. And everything is connected. We have a score of 100%. And so that's going to conclude another lab tutorial for the Test Out PC Pro version 6 course. And this was for lab 2.5.6. If you have any questions or you have any concerns, don't hesitate to reach out, contact your instructor, and I will see you in my next video.
2.2 Practice Questions Explanation. Alkaline batteries manufactured after 1996 are made of relatively non-hazardous materials and can be tossed directly into the trash in most states. There is no need to send them to a hazardous waste collection. Alkaline batteries do not have an expiration date that needs to be met before they can be thrown away. Technically speaking, an alkaline battery can be recharged, although most manufacturers tell you not to recharge them. If you recharge an alkaline battery, you risk an explosion, and you will have a low-quality battery if the charge is successful. Storing the batteries on-site until they expire does not address the issue of proper disposal. Explanation: laptop batteries contain hazardous materials such as mercury, cadmium, and lead. Therefore, these batteries must be recycled or given to a hazardous waste facility. Because the toxic substances in laptop batteries can harm the environment, such as entering the food chain, adversely affecting plants, animals, and humans, they should never be thrown in the trash. Since new computers come with their own new battery, there is no need to recharge and keep the old batteries. In addition, these batteries lose their holding capacity and will most likely not be able to power a device for any usable length of time. Laptop batteries do not need to be kept on site until a certain expiration date has been met. Once you are done with them, they can be recycled or deposited at the hazardous waste facility. Explanation: NiCad, NiMH, and other notebook battery types can contain regulated materials. Read the battery's documentation for a description of correct disposal procedures. Incorrect disposal can result in serious fines. While using special recycling services when disposing of computer components is environmentally friendly, most locations do not have laws regarding the disposal of most common components such as motherboards, video cards, and hard disk drives. Explanation: corrosion of server components is a sign of high humidity in the environment. And San Francisco is one of the highest humidity cities in the United States. The recommended humidity level is usually between 50 and 65%. The best solution in this scenario is to decrease the amount of humidity in the data center to an acceptable level. Replacing motherboards is costly and is not the best solution in this scenario, given that the new motherboards will probably also corrode. Cleaning the server components will not solve the issue of continuing corrosion. While KD could run diagnostics to check for server performance, this approach would not solve the issue of continuing corrosion of server components. Explanation: empty printer cartridges should be returned to the manufacturer for recycling. Most manufacturers accept the empty cartridges back from you, refill them, and then resell them. This reduces landfill waste, provides the manufacturer with a cheap source of empty cartridges, and provides you with a source for less expensive printer cartridges. While local recycling facility will only recycle the cartridge plastic. The best solution is to have the cartridge refilled for reuse. Placing a printer cartridge in the regular trash simply results in the cartridge being added to a landfill. You should recycle the cartridge. Placing the printer cartridge in a standard recycling bin can result in the cartridge being sorted out for being thrown into a landfill. The best solution is to have the cartridge refilled for reuse. Explanation: server rooms and data centers often use hot and cold aisles that are designed to ensure that hot air is removed and cool air is pushed into the room. Internal fans, cooling systems, and a well-maintained temperature are important, but do not assist with the ventilation concerns in a server room. Explanation: the dimming or flickering is most likely caused by a drop in the voltage to the lab due to the large number of computers being run at the same time. This drop in voltage is known as a brownout and can be harmful to your computers. You should take steps to maintain a constant level of electricity. Power surges, also called power spikes, are abnormally high voltages that last for short periods of time. These can also be harmful to your computers. A blackout is a total loss of power. A power spike is like a power surge, but it lasts for milliseconds instead of seconds. Explanation: due to the periodic high power requirements to heat the fuser roller, a laser printer should not be plugged into a UPS's battery backup outlets. Instead, a laser printer should only be plugged into the surge protection outlets or directly into a wall outlet. Inkjet printers, external hard drives, and secondary LED monitors can be plugged into battery backup outlets. Explanation: a typical UPS protects a computer from overvoltages as well as undervoltages. Also, because the quality of the electrical signal provided by a UPS battery is not as good as the AC power from the wall outlet, UPS devices often have built-in line conditioners. A UPS unit does not prevent electric shock, prevent ESD, or protect cabling from ME. Explanation: an uninterruptible power supply, UPS, is a device that contains a large battery suitable to run the attached devices for an extended period of time in the event that power is lost or drops below an acceptable level. A UPS can protect your computers from brownouts, power surges, and blackouts. UPSs can be purchased in varying size to accommodate large server or individual computers. A surge suppressor is typically a small box with several utility outlets, a power switch, and a 3-wire cord for plugging into a wall outlet. The purpose of this device is to protect the electrical devices plugged in the suppressor from voltage spikes or power surges. A surge suppressor will not protect equipment from a drop in voltage. A power strip can sometimes include a surge suppressor, but often only provides a way to plug multiple appliances into an on-wall outlet. A ground fault circuit interrupter, GFCI, is a protection device designed to protect people from electric shock from an electrical system. A GFCI protects you from ground faults, such as an electrical short. You often see these outlets in bathrooms and kitchens, where the chance of an electrical shock is greater due to water.